So the reason that people use a honeycomb bed, and I've seen people DIY these, it's basically a mesh aluminum frame. You could see it's see-through, held together with a couple rods, and then it's like a U-channel aluminum frame as well. The one that I'm testing has more of a solid base and these spikes, but the reason I was interested in it was because of this T-track. I cut a lot of thinner material, which as it heats up bends, and you can easily ruin an entire project because of that issue. So the reason people use these is the smoke clears a little bit easier, which is why there's these grooves and it's elevated off of the table. It goes through the grooves, but also so you don't ruin your tabletop. I believe there's a spot on this table somewhere. Here it is, where I forgot to put this aluminum mat, and it will cut through to any surface. So a lot of times with this, they'll also ship this thin aluminum mat. It goes underneath, it protects your surface. So this one's a little bit different. It's got more of a solid surface with these grooves on the bottom to help with the smoke escaping. The reason I wanted to test this one is because I cut a lot of thinner materials, and I've especially been playing around with veneer, which is very thin and hard to adhere solidly to this honeycomb bed. I printed out a pattern that uses these little almost clothespin-like things in the bed to hold stuff down, but the problem is even the veneer is too thin for them and it doesn't really hold, so then I have to put something underneath of this. It becomes a little bit of a hassle. So basically the reason I agreed to review this is I thought it would solve this problem, and for the most part it did. I had to make a couple modifications, which you'll see in the video, but I also think that not a lot of people are cutting thinner materials, so I don't think this was designed for that. The most common material you'll see people cut for patterns and stuff that you can buy online is 1/8 inch to 1/4 inch plywood. This works great with that. So basically I just wanted something to hold this down. It's this veneer, which you'll see in the video, starts lifting when it gets hot. All of these materials, the thinner ply, when the laser heats it up, they start warping. And the laser head will get caught on it because the laser is only lifted a little bit from the table. That's my first issue I have. The second issue is, as this material gets hot and lifts, the focal point that you have set on the laser changes, so sometimes it won't cut all the way through, which could be a real pain if you're making pieces that need to be cut out. You spend 2 hours cutting out an intricate pattern, and some of it won't pop off from the material because the focal point has changed when this has warped, and it's no longer cutting through properly. And the other thing is when this does, it's kind of in the same vein, but especially on intricate patterns, as this material warps, and I'm using this as an example, but I've had the same issues with 1/8 inch ply and 1/4 inch ply. As this heats up and warps, your pattern gets distorted. It's just kind of a basic principle here. As the dimension of this changes, your pattern will change on it, and I've ruined projects that way as well. So that was kind of the catalyst for testing this, because I already had this honeycomb bed. In general, I do really like this. I think it's going to solve a lot of my problems with cutting thinner material. I'll show you a couple of the issues I had, which was easily fixed in the shop. But if you're in the market for a honeycomb bed, I did really like this one, and I think it might become my primary bed versus these aluminum ones. So my other issue with these aluminum beds is, while these little pins I made work really well, the more I use them in the bed, they're distorting the aluminum, and I think eventually over time it'll be distorted so much that they won't really work. So I was kind of already thinking of a different method for tacking this stuff down. It's really important to just have it flat, again, as flat as possible against whatever you're burning it up against. So this company is AtomStack. I've reviewed a laser for them before. I believe I'm doing another one as well, and they are sending me a bunch of other add-ons to review. The first of these is going to be this honeycomb bed, and like I said, I don't love reviewing some of these side components because I've tested so many at this point. They're all pretty similar. but I did like the difference. And the other one that will be coming out next week is a camera for the laser. So this stuff comes in smaller boxes, which is nice. You'll probably save on shipping if this is something you want, but it does require assembly. I'm not going to go through a detailed guide of doing it. It's very straightforward. It went together extremely quickly. You basically make the outer frame, slide in all the components, and then put the last piece of the frame on, and then you're ready to go. So this is, like I said, these spikes that hold up. It helps evacuate the smoke faster, but honestly, you should always be using this stuff with some sort of vent, which is going to be the fastest way to evacuate the smoke from any of these laser engravers. You can see I'm just putting it together, and then I'm going to be ready to go. And the thing I was most interested in, as I will say throughout this video, is the T-track on the side. So I started by placing a piece of veneer on there. That's what I wanted to test first. And it was looking pretty good, but because of the size of the T-track pieces do not extend past the middle of the board. They only go about 2/3 of the way across. So I had to orient this in a different way. So I was originally doing it diagonally, and then I had to do it lengthway. And when I did that, I noticed that these flanges, because they're lower on the outside of the frame, were being pushed up the further you tighten them, which wouldn't work for this. You could see there's too much flexion with this thinner stock, and what I wanted. An easy fix for this was I added 2 washers, which are essentially spacers in this situation, onto the wing nuts, and that was what held it down. So that was an easy fix to get this to work with thinner material. If the company wanted to make an improvement on this design, I would say make these finger slots that hold the material down longer, and also maybe send a set of spacers for the different thickness and material. That would be the 2 big improvements in this design. But like you'll see in the video, they were easy fixes in the shop. To account for the fact that these fingers didn't go across the whole piece, I had some thin aluminum in the shop that I used to span the gap in between the fingers. That worked really well to hold this down. You'll see I left one side free of that because I wanted to show how the material will warp as it heats up. And you can see on the edges it's warping and heating up and changing, but it's so far away from the design that doesn't really matter. On the side where I added the aluminum, it was keeping it very flat and true, which I was extremely happy about. And then on the side that didn't have that, you'll see later the laser actually catches it, because the gap between the protective cover over the laser and the piece you're cutting, no matter what the thickness is, it's very small. So I wasn't filming when it happened, which is unfortunate, but basically what has happened to me since I started doing this, which is the material heated up, it warped, and the laser got caught on it and ripped it. You could see how much flexion there is in the side, and if I move this by hand, you can get an idea of what I'm talking about. The laser gets caught because that changes the dimension. It lifts it up just enough to get caught on that rim, which is what it did here, and it ripped that apart. I have ruined countless projects because of this. I've been constantly trying to figure out ways to keep this from happening. You can see, looking at the pattern on the side, that was held down nicely, turned out beautifully, but as you get further away, you start to get more burn marks, and the pattern isn't as perfect because it started moving. The next thing I'm going to try is 1/8 inch ply. This I use quite often. I know a lot of people buy or make patterns on Etsy. I've gotten a lot of patterns that way, and the most common material that is used is 1/2 inch or 3mm to 4mm plywood, they'll say, and 1/4 inch plywood. So this one worked really well. You can see I have a bigger piece. I'm working on the corner, which is usually where I have a lot of issues with the material moving. But because I have those flanges across all 4 corners, this stayed flat the entire time. it cut through. Obviously I'm using scrap, so there's other patterns on here. I moved the laser to another side and I had the same positive results. This didn't shift or change at all, and it was very easy to align those flanges in order to keep this down. You can see I'm pushing on the whole thing. The only thing that's flexing is the actual bed, not the wood that you're cutting. And then I tried engraving and cutting with that. You can see when I move the fingers that it does want to pop up, so it was successfully holding this down. The next thing I used was 1/4 inch plywood. Like I said, I use this a lot as well. And then this is where having a set of spacers would come into play. Because of how far down the T-track is, as you use thicker material, you have an issue where now the fingers are lifted off. It worked out in this circumstance because I had a big enough piece of wood and my design was going in between, but you might run into an issue where if you have a smaller piece, the laser will hit those flanges. These are tokens I make for my brother-in-law. It cut those out perfectly, no issue. If you already have a honeycomb bed, and I think I might do this to mine, if you have some T-tack laying around with some T-bolts, then you can easily add a spacer to the honeycomb bed and make this yourself. The problem is if you don't have these materials, I just priced them out real quick on Amazon, you're looking at $50 in hardware before you even buy the honeycomb bed. This one was about $90, and the other one I have in my shop was about $70. The one that AtomStack just gave me, I believe, is about $120. The other issue I had with this is the T-bolts are very small, so sometimes when you're loosening it, they want to lift out of the slot. You can see regular T-bolts and T-track are much larger, and I don't think you'd have that as much of an issue with that. And then the last little bit of this video is just showing you a bunch of times the laser's messed up. On veneer, I've been using tape before to hold this down. That kind of worked. You can see on this thinner material I was cutting, just by the shadows created, how much this material lifted, and I would use tape to try and keep it all down. Like I said, that sort of stuff works, but you really have to keep an eye on the machine. And then towards the end of my learning process with these lasers, I had, like I said, these aluminum pieces I was using to hold down thin stock. The problem with that is they're not held down with anything, they're just sitting on top of the table. So it would be nice to be able to clamp them down. And then with veneer, I was always using a series of weights and even using my hands as the machine went to keep things flat. You can see how much they lift once you move those weights. So I'm really hoping that with playing around with this new bed, it solves a lot of problems